Hey everyone, and welcome. Today we're diving into a technology that could totally change how we interact with our digital world. It's called ISAC, and it's set to give our wireless networks a brand new superpower, the ability to sense. Let's get into it.
So I want you to just think about this for a second. We're so used to our wireless networks just, connecting our phones, our laptops, all the usual stuff. But what if those very same signals could actually perceive the physical environment? It's a huge shift in what a network can even be.
All right, so here's our game plan. We'll kick things off with the big idea, then we'll get into the nitty-gritty of what ISAC actually is and how it works. After that, we'll look at some really mind-bending real-world applications, and finally, we'll see how this whole thing is paving the road to 6G.
For decades, wireless technology has been laser-focused on getting better and faster at just one thing, communication. But now, we're about to add a second, incredibly powerful job right into the network itself.
So, remember that big question I asked at the start? The idea of a network that can literally see? Well, guess what? It's not just some cool what-if scenario. It's a real technology, and it's called Integrated Sensing and Communication, or for short, ISAC.
Okay, so here is the single most important thing to understand. ISAC isn't about adding more stuff, like more towers or more antennas. Nope, it's about making the infrastructure we already have way, way smarter. It basically merges two completely different jobs, communication and sensing, into one single, hyper-efficient system that uses the same signals and hardware for both.
And this slide just lays it out perfectly. Right now, we live in a world of separate systems. You have a 5G network for your phone and a completely separate radar system for a self-driving car. Different hardware, different radio frequencies, the whole deal. With ISAC, we're moving to a world where one integrated network does it all at the same time. This isn't just an upgrade, it's a complete redesign.
So we know what ISAC is, but now let's talk about why it's such a massive deal. Why go to all the trouble of combining these two things? Well, the answer is pretty simple. The payoff is absolutely huge. And this right here, this is the secret sauce. Because you're using the same hardware and the same slice of the airwaves for two jobs, you're not just saving money and power, you're making the entire system more efficient, more agile, and you're opening the door to services that, until now, have pretty much been science fiction.
And that's really the key takeaway. ISAC is all about a smarter, more sustainable way forward. Instead of just building bigger and more powerful networks, we're building networks that are more intelligent and a whole lot more resourceful.
Okay, so I know what you're probably thinking. How in the world does a wireless signal see anything? The physics can get a little complicated, but don't worry. There's a perfect analogy from the animal kingdom that makes it all click into place. Yep, that's it. It works just like a bat. A bat sends out a high-pitched sound, and it builds a mental map of its surroundings based on the echoes that bounce back. Well, a wireless network with ISAC does almost the exact same thing, but it uses radio signals instead of sound.
So let's break that down. At its simplest, a device like a cell tower sends out a radio signal. That signal flies out, hits something, like a car or a person, and then bounces back, creating an echo. That same tower then listens for that echo to figure out what's out there. That's called monostatic sensing. It's like one bat listening for its own call. But this is where it gets really cool. What if a different device, maybe another tower or even your phone, is also listening for that same echo? Now you're getting a second perspective on that object. This is bistatic sensing, and it starts to give you a much more accurate idea of where things are.
And now just imagine scaling that up. Imagine dozens or even hundreds of devices all listening to these echoes from countless different angles. By weaving all that information together, the network can create this incredibly rich, super detailed digital map of the physical world, all in real time. The entire network becomes one giant collective sensor.
And by analyzing those echoes, looking at things like the time delay, the shift in frequency, the angle they come from, the network can figure out all this crucial information. It can determine an object's exact location, which direction it's headed, how far away it is, and exactly how fast it's moving. Okay, so we've covered the what, the why, and the how. Now for the really fun part. What can we actually do with this technology? Let's jump into some of the real-world applications that ISAC is going to unlock.
Let's start with self-driving cars, because this is a big one. With ISAC, a car isn't just communicating with the car in front of it. It's using those very same signals to also sense a pedestrian about to step off the curb or a cyclist hiding in its blind spot. It's a two-for-one system that dramatically boosts safety and awareness.
Or get this.
Imagine controlling your smart home devices just by waving your hand in the air. No camera, no remote. The Wi-Fi network itself would be able to sense the subtle ways your hand gestures disturb the radio signals and translate those into commands.
This could be absolutely revolutionary in healthcare. A network could monitor a patient's breathing rate or even their heartbeat just by sensing the tiny movements of their chest. All of this without any uncomfortable wearables or wires needing to be attached to their body. It's incredible. And in the industrial world, this is a total game changer. Automated vehicles and robots in a factory can be coordinated with near-perfect precision because the network is simultaneously talking to them and sensing their exact location and movement, preventing collisions and making everything run smoother. Now, I know some of this still sounds a little like it's from a movie, but trust me, this isn't some far-off dream. ISAC is being actively developed as we speak, and it's widely considered to be a core foundational piece of what will eventually become 6G.
And look, this isn't just an idea on a napkin. As you can see from this timeline, the groundwork for ISAC has been getting laid for years. Right now, we're deep in the technical development phase, hammering out the core architecture and the rules of the road. The end goal? To have ISAC as a standard, built-in feature of the 6G networks that will start to show up around 2029 or 2030.
Of course, it's not all easy. There's still some pretty big challenges to figure out. How do you make sure the sensing signal doesn't interfere with someone's video call? How do you design a single radio signal that's great for both high-speed data and high-resolution sensing? And maybe most importantly, how do we make sure all this incredibly detailed environmental data is kept secure and private? These are the tough problems engineers are working to solve right now. So that brings us right back to where we started with a question for the future. As our digital networks gain this new sense, this ability to perceive the physical world, we're not just getting a faster internet. We are building a world that is contextually aware, a world that can anticipate, react, and assist us in ways we are only just beginning to imagine. Thanks for tuning in.